Oh, good afternoon. I'm Mr. Precella. I want to remind you that the link to the class video lecture playlist on YouTube is here under announcements on Canvas. What is it? Second from the bottom, it looks like. And today we're going to be discussing circles. Make a note that this is where Test 2 begins. We're finished with Test 1 material. We're beginning our journey through Test 2 material. I believe all of y'all are familiar with the concept of a circle. You know what it looks like. And you know that there's a point right there in the middle that we call the center. The formal definition of a circle is the set of all points that are equidistant from a fixed point. That distance from the center to the outer edge is called the radius. And it's the same in any direction. If you go from the center to the outer edge of the circle, that distance is the same. Well, this is an algebra class, not a geometry class, so we're not going to take a geometric approach to circles. We're going to take an algebraic approach. We will be graphing circles using the center and the radius and a very nice MyLab graphing tool. So we will be doing a little geometry with circles, not much, just graphing them. When we're taking an algebraic approach to things, we always like equations. In algebra classes, we like variables and equations. So, I'm going to use the standard practice, I should say. It's not something I just made up. Every algebra textbook out there uses the coordinates HK to represent the center of a circle. H is the x coordinate of the center. K is the y coordinate of the center. And what letter do you think they use to represent the radius? It's an obvious choice. R, I agree. Then we have something called a center radius form of a circle. Center radius form of a circle is x minus the x coordinate of the center, that's h, quantity squared, plus y minus the y coordinate of the center, quantity squared, is equal to the radius squared. And this equation can be derived pretty easily using hk as the center and xy is an arbitrary point on the edge of the circle, and we know that the distance from the center to that outer edge is the letter r. All they do is, using the distance formula, they square both sides. That drops the square root from the distance formula. You pick up a square on the radius, though. Let's suppose the center is 0, 0. Let's suppose that the center of the circle is 0, 0. And let's suppose that the radius is still just lowercase letter r. If the center is 0, 0, then we have a very nice equation, because think about what's happening. You have x minus 0. X minus 0 is what? Just x. So we have x squared plus. Now the k value is 0. What's that going to reduce to? Y minus 0. It's just going to be a y equals radius squared. So if your center is at 0, 0, all you have on the left side of the equation is x squared plus y squared equals the radius squared. And looking at number 1. Oh, let's see. Oh, by the way, I'm no longer requiring y'all to click these things here in order to start the questions. But if you don't at least click them, you don't have to watch them all, but if you don't click them and get that green check, you're not going to make 100 on the assignment. And I have had an email about that. You've got to click them to get that green check, even if you're not watching them, or even if you get all these questions right here, you're not going to make 100. So looking at number 1, find the center radius form of the equation of the circle with the center at 0, 0 and the radius at 14. Radius 14. So this is number 1. Let me write the problem down. The center is at point 0, 0 and the radius is 14. All circles that are centered at the origin are always the easiest to graph. You'll see what I mean when we start graphing this thing in a minute. But we know 0 is acting as h and 0 is acting as k. So that means x minus 0, that's just an x squared, plus, what are we going to get for the y terms? Y squared equals, what are we going to square here? 14 squared. 14 times 14 is not 196. I better check my mental arithmetic. Oh, where's my calculator? I'll check it. Let's see. Clear all that off. 14 squared. 196, yes. So here's my equation. So I'll come over here. And is this the first time we've typed in exponents? For some reason I'm thinking it is. Yes? Y'all remember typing in exponents? Okay, you click in the blue box, X, and look down here. This third box here on the toolbar. There's a gray box, and then the little exponent is a blue box. That's the one you want to use. Notice it says superscript. I don't know why it just doesn't say exponent, but it puts superscript, meaning something that's written up high. So you click that, you get the blue box, and you type your square. But is this what we want? No, you don't want that plus in the exponent. Do a right arrow or click with your mouse, what have you, to get plus y square equals, what did we say, 196? Any questions there? Now, usually with questions that have A and B parts, you have to use part A to answer part B. That is not the case here. To draw a graph, all you need is, if you're drawing a graph, I'm going to make a note here. To graph a circle, you use the center and the radius. You don't use the equation. You use the center and radius. They could have asked us to draw the graph before the equation. So, to graph a circle, use the center and radius. So coming over here, I really like this graphing tool. Do y'all pop the graphs out when you're using the graphing tools the way we do, or do you use the thing over here? Either way, I pop it out. I didn't used to, but it seems to work better nowadays like that. We have to choose choose the tool to draw the graph. Once again, you have to know this is a circle. I think we could pick out the tool without even hovering. There's only one figure there that looks like a circle. Which one is it? Is this it? If you hover right there, it says circle tool. That's right. So we click it, and now it says plot the center. Well, the center is at 0, 0. Notice up there in the upper right-hand corner of that yellow box, it says 0, 0. Notice how small those increments are. Yesterday we did an example where the units were in half increments. So you need to be looking up there at that box to make sure that you have the coordinates that you want. You click that. Then the instructions say, click the graph to plot another point on your circle. Well, wait a minute. We don't have any points on our circle. That's where the radius comes in. The radius was 14. So move up, down, left to right 14 units. Notice as you move your mouse, notice how it's moving, drawing in the circles. It's drawing every circle that has a center at 0, 0. Well, the radius is 14. I think I'm just going to count 14 units to the right. So that's going to drop me off at what number on the x-axis? It should be obvious. Is that it? No, we want 14, 0. Now, if you had counted up, notice if you had counted up, there it is, right up there. That's 0, 14. If you'd gone to the left, you'd be at negative 14. If you'd gone down, you'd be at negative 14. So just locate the center, and then whatever the radius is, that's how far you have to count. So remember, you save it to transfer it back to the original grid and check answer. Any questions there? Well, they won't all be centered at the origin. Number 2. We want to write the center radius form. This is number 2. Write the center radius form for the equation of a circle that's centered at negative 1, 3. And the radius is 4. And I'm going to write center radius form down again in terms of x and h. X minus h quantity squared plus y minus k quantity squared equals the radius. What number is acting as h? Okay. What number is acting as k? Okay, I agree. And we know the way I wrote it, r equals 4. We know the radius is 4. So we have x minus y minus, okay. What's going to go after the x minus? A negative 1, I agree. Here, I agree. And here, I agree. This problem is going to illustrate a very important concept. X minus a negative 1. Minus a negative becomes what? So we have an x plus 1. We can clean that first set of parentheses up just to be x plus 1 squared. Y minus 3, that'll just stay a y minus 3 squared, equals 16. We're not through with this problem, but any questions up to this point? Still have to draw the graph, but before we do that, I want to make an observation. This is an important observation. What you see inside these parentheses in center radius form is exactly the opposite of the center. we have a +1 and a -3. But the center is -1, +3. What you see inside the parentheses is exactly the opposite of the center. Eventually, they're going to start giving you the equation, and you'll have to go back to the center. So what will you do? Change sign on the number paired with x, change sign on the number paired with y. What do we do here to go back to the radius? What's going to undo that squaring? What will we do if we didn't know the radius, but we knew that number was 16? What would we do to get back to the radius? No. What undoes squaring? A square root. So change sign, take the square root. Well, let's type that answer in. So, now I see these parentheses down here on the toolbar, but I don't use them. That's really intended just for an ordered pair, and we don't have an ordered pair. We have a x + 1 inside the parentheses. We have a y - 3. So when I have to type parentheses, I just use the parentheses from the keyboard. There, x + 1, right parenthesis. Then I use my exponent, hot button, square. What do I need to do before I type the plus? Move it over. I just use the right arrow on my keyboard. Plus, left parenthesis, y - 3, right parenthesis, squared. Get out of the exponent before I type equals 16. And notice, I'm not hitting any space keys. You shouldn't ever have to use that space bar. You shouldn't have to use capital letters. My lab does all the spacing for you. Okay, let's draw the graph now. We click the circle tool. Oh, and if you look at this circle tool very closely, can you see, it's hard to tell colors, but the center is in blue, and then there's one other dot there in blue. That's saying that's what you're going to do. You have to use the center and one other dot. How do you find that other dot? That's where the radius comes in. So we click the circle tool. The center was at -1, +3. Is that it? Yes, so I click. What was the radius? Not 16. The square root of 16 was, what did they give us as the radius? The 4. Okay, so we're going to have to count 4 units in any direction. Here I am, right there. Do y'all want to count 4 units? Up, down, left to right. It doesn't matter. We'll get the same circle either way. So what do you want to do? How about we go up? 1, 2, 3, 4. So we were at 3. We moved up 4. We're now at 7. Is that what I wanted? Yes. If I move to the right, 1, 2, 3, 4, I'd still have that same circle. Any questions there? Okay, number 3. It's another right the center radius form. Let me write the problem down first. The center is at point 3, -4. And the radius is 7. Okay, what number's acting like H? 3, I agree. What number's acting like K? -4. And the radius is 7. So notice how I'm going to write this. I know I have an x minus, I have a y minus, and I'm going to be squaring something over there. Now we'll fill in the blanks. What's going to go beside the x minus? The 3, the h value, I agree. What's going to go beside the y minus? -4. And here, 7, I agree. So x minus 3, that's just x minus 3. You're going to see in a little bit that you really never want to expand this. If I were going to square x minus 3, I couldn't just square the x and square the 3. What do we have to do? A binomial times a binomial. If we were to expand this and get rid of those parentheses, how would we multiply? 4-letter word beginning with F. FOIL, yeah, that's something that you wouldn't want to do. There's no time you ever want to do that. And if someone goes through and expands those and wants you to draw the graph of the circle, you're going to have to work your way backwards to get it in center radius form. You'll see what I mean in a little bit. What about this y minus -4? Let's clean that up. What's that going to be? Okay, that becomes a positive, and 7 times 7 is 49. For my center radius form. And just like I said earlier, notice the numbers that you see inside the parentheses are exactly the opposite of the center. You see a -3 and a +4, that's not the center. The center is a +3, -4. So if you have the equation and you want to go back to the center, change sign, change sign. What do you do to this number to go back to the radius? Take the square root. And that will be important in a few minutes. So, left parenthesis, x minus 3, right parenthesis, use my exponent hot button, square, right arrow to get out of the exponent position, plus left parenthesis y plus 4, right parenthesis, squared, get out of the exponent before you type your equals 49. Any questions there? So now we got to draw the graph. Notice you're not using the equation to draw the graph. To graph a circle, you're using the information they gave you. They gave you the center was at 3, -4. Click your circle tool. Go to 3, -4. Is that 3, -4? Yes. And the radius was 7. Well, what do you want to do? We got to count 7 units. How about we count it to the right? Here goes. 1, 2, 3, 4, 5. Is that it? We started at 3. We added 7, so we should be at 10. Is that it? It's hard to count, even when I'm looking at this screen right here. It's hard to count those little spaces. That's why the points that they have up here in the upper right-hand corner of this yellow box is so important. Save it. Check. Any questions? Hold on. I have another one, so when I break the little earpiece, like I frequently do. Number 5. Okay. So we're going on. Number 4 is just like 3. So number 5. Let's write the problem down. Here the center is at the point 0, -1, and the radius is 2. Same instructions, write the center radius form and then draw the graph. What number is acting like H? 0, okay. What number is acting like K? -1, and we know the R value. So we have X minus, Y minus, there. What number is going to go here? 0, here, -1, here, and X minus 0, that cleans up very nicely just to X minus 0 is equal to X, so we have an X squared plus, what's going to happen with these double negatives? Okay, and 2 squared is 4. So notice, if just one of the terms becomes of the center is one of the coordinates is 0, then you just have the variable squared for that coordinate. There's my final answer. So we have an X squared, get out of the exponent, plus, left parentheses, Y plus 1 squared equals 4. Is that what I wanted to type? Yeah. And click the circle tool, and we're not using the equation, we're using the center, 0, -1. There's the center, and the radius was 2. Oh, let's just count 2 units to the right. 1, 2. And notice once again, if you'd counted 2 units up, or 2 units down, or 2 units left, you would have still gotten the same graph. Any questions there? Here they want us to graph the circle. This is number 6. X minus 8 quantity squared plus Y plus 5 quantity squared is equal to 4. If we're going to graph a circle, we need to know 2 things. What are they? The radius and the center. We're going to have to find the center and the radius from this equation. I've been warning you of that. Remember I said to go backwards. Here's the equation. To go backwards to the center, change sign, and what do you do to this number to go back to the radius? square root. So the center, what's the x-coordinate of the center? 8. Change sign. The y-coordinate, -5. The radius, you take the square root of 4, which is 2. If the equation is in center radius form, it is very easy to go back to the center and the radius. Change sign, take the square root of that number on the right. And now we have the center and radius, we can draw the graph. So we click our circle our circle tool, and the center is at 8, -5, 8. Is that what I said? 8, -5. Is that it? Yes. And the radius is what? 2. How about we just go 2 units to the right then? 1, 2. Click it to save and check answer. Any questions there? Change sign, take the square root to determine the radius, provided the equation is in center radius form. Number 7, let me write it down. X plus 3 quantity squared plus y plus 2 quantity squared is equal to 9. This is in center radius form. Squared stuff plus squared stuff equals a number. So we can just look there and determine the center. The center, what's the x-coordinate of the center? -3, change sign, I agree. Here, -2. The radius, we take the square root of, which gives us 3. And that's all we need in order to draw the graph. Change sign, take the square root. Click the circle tool, and what was it, -3, -2? -3, -2. Is that the center? Is my mouse where I want it to be? Yes, it is. And then we have a radius of 3. Let's just count 3 units to the right. 1, 2, 3. Any questions? As long as the equation is in center radius form, then everything works out fine. You can change sign, take the square root. Suppose someone went through and removed all these parentheses by squaring the x plus 3 and the y plus 2. Maybe they even combined all the constant terms. Let's see. Let's expand center radius form. This is the only time I'm going to do this, because that is not something that you really want to do, at least from an algebraic point of view. Suppose we had x plus 3 squared plus, I'm just going to use this number 7 that we were doing, but realize we're through with number 7. I just needed a circle to use as an example for what I'm about to do, so I decided I'd use the one that was sitting there on number 7. Okay, but this is starting, that's not number 7. X plus 3 squared, that means x plus 3 times x plus 3. Plus y plus 2 squared, that's y plus 2 times y plus 2. It's a binomial times a binomial. We're going to have to FOIL that out. So here goes. Y'all tell me the products. First, x times x, x squared plus outer, 3x plus inner, another 3x plus last. So the x plus 3 quantity squared reduces to x squared plus 6x plus 9. X squared plus 6x plus 9 is called a perfect square trinomial. It has 3 terms, that's what makes it a trinomial, and when it's factored, notice you have the same thing inside both sets of parentheses, so it can factor just as the binomial squared. Let's FOIL out the y plus 2 times the y plus 2. First, y squared, I agree, outer, inner, last, and we have a 9 there. So we can clean up those y terms. That's just a y squared plus a 4y plus 4. We still have that 9 sitting over there on the right hand side. And how about we now rearrange the terms? Let's put the terms in alphabetical order based on exponents. So we would have the x squared plus y squared first. We have x squared plus y squared. And then we have the unsquared variable, 6x plus 4y. And how about we move all these constants over to the right? Let's subtract 9. 9 minus 9, what happens there? Let's move that 4 over. So what are we going to have over here on the right-hand side? A negative 4, I agree. This form here is called general form or expanded form. I prefer the name expanded form. And from an algebraic point of view, now if you're looking at partial derivatives or something in a calculus class, that expanded form might be very nice, okay? If you're looking at explicit differentiation, but that's not what we're doing. So from an algebraic form, there is nothing nice about this expanded form, okay? From an algebraic view, I should say. Because if you're looking at that, can you still just look there and change signs to get the center and the radius? Can you just look there and just easily know the center and radius? You can't, not in expanded form. You can if it's in center radius form, but not in expanded form. And that's the big problem. We're going to have to go backwards. They're going to start giving us these equations in expanded form. We're then going to have to go through and create perfect square trinomials. This process of creating perfect square trinomials is called completing the square. And when we were looking at solving quadratic equations, I made the remark that we were going to delay completing the square until we got to circles. Now we're at circles, so we need to look at how you complete the square. Completing the square is the process of creating perfect square trinomials. And well, in this example, we already have some perfect square trinomials. X squared plus 6x plus 9. That factors is x plus 3 times x plus 3. And I'll just write it as x plus 3 quantity squared. This y squared plus 4y plus 4. That's an example of a perfect square trinomial. And that factors just as a y plus 2 squared. Realize when the equation is written in expanded form, you have your x squared, you have your x term. You don't have that special number that's sitting there. That's the number you're going to have to figure out. You have your y squared plus your y term, but you don't have that other number sitting there. So let's see. Let's make some other perfect square trinomials. See if y'all see the pattern. X squared minus 10x plus 25. A perfect square trinomial may have a minus. And recalling our factoring rule, if the last sign is plus, you have two of the first signs, x and x. What will we use here and here to give us back x squared minus 10x plus 25? 5 and 5, I agree. So x squared minus 10x plus 25 factors is x minus 5 quantity squared. How about x squared minus, oh, I got a good one, 20x plus 100. How would we factor that? I'll get us started. X and x. What do we know about the signs? Okay, this plus or minus. Minus and minus. And then I asked, what would you use to get last times last has to give you 100. 10 and 10, I agree. And if you FOIL that out, negative 10x minus 10x gives you back that negative 20x. So that factors as x minus 10 quantity squared. But the thing is, it's this number. That's the number you're going to have to figure out in the process based on these first two terms. So let's see. You're trying to figure out this 25. What could we do? Well, the only numbers we have is that number sitting there in front of the unsquared variable. We have to do two things to this number to give us that 25. What are the two things? I'm looking for a pattern here. Suppose I have an x squared plus 16x plus a blank. What would I put there to create a perfect square so that it factors as a binomial squared? Go back here. I think it's easiest, maybe it's easiest right here. That's 6. What do we have to do to 6 to give us 9? Remember, the process is called completing the square. So somewhere along the way, you're going to be squaring something. I couldn't hear you. What do you square to give yourself a 9? A 3? Isn't 3 half of 6? What about this? Half of 10 is 5, and when you square it, what do you get? A 25. Now, technically, that's a negative 10. And so half a negative 10 is a negative 5, but you square the result, and if you're squaring something, what are you always going to get? Are you going to get a negative? No, you're going to get a positive. So I only look at the middle, I just look at the number part, not even the sign. Half of 20 is 10. 10 squared is 100. Okay, follow that pattern and tell me what number is going to have to go right there. Half of 16 is, I couldn't hear you, 8. 8 squared is, 8 times 8 is 64. And how is that going to factor? Variable. What sign am I going to have here? Plus. What number will I have here? Okay, remember you want it to something times something to equal 64, so 8. There's a pattern. You take half of that number and then square the result. And then when you're factoring it, it's variable. Whatever that first sign is, half of that number. Half of 16 was 8. Variable x, that sign right there minus half of 20 was 10. Any questions there? That's how you create perfect square trinomials. I have another question. Using this process, if you look at, here's your center radius form. When you start going through expanding and foiling, what is your leading coefficient going to be? Do you have a number sitting there in front of x other than 1? No. So what should be the coefficient of x squared? It better be a 1, hadn't it? So this process doesn't work if those square coefficients aren't 1. Well, suppose they weren't 1. Suppose it was a 2 or 3. We'll see a way to get around that. So let's look at number 8. Number 8. Oh, look at that. Look at number 7. It was so nice. They gave us an equation in center radius form. Change sign, take the square root. The instructions say graph the circle. Number 8. We have to find the center radius and draw the graph. But it's not anywhere nearly as easy as the one before that because this is not in center radius form. It is in expanded form. Let's write the problem down and make sure we don't miscopy, because if we do, that'll throw us off a lot. X squared plus y squared minus 10x plus 4y is equal to 35. X squared. Okay. Realize the most fundamental type of problem-solving skill is if you know how to work a problem that looks one way, try to make the new problem look the same as the old problem. That means what we need. We want the equation to be, here's what we want. We want something squared plus something squared equals a number. That's what we're trying for. Because if we can get it in center radius form, change sign, take the square root. So what I'm going to do, I'm going to group the x terms together. X squared minus 10x. X squared minus 10x plus, I'm going to skip some space there. We're going to have to add a number in there to make it a perfect square trinomial. So it'll factor as something squared. Plus, now let's group the y terms together. We have a y squared plus 4y plus we have that 35 on the right hand side. Realize these equals are like those old-fashioned scales. We're adding 5 pounds to one side, so we've got to add 5 pounds to the other side to maintain the balance. So whatever we add here, that green blank, we're going to also have to add it to the right side. Whatever we add here in this red blank, we're going to have to add it to the right, to the right side also, in order to maintain the balance. And I just started to write in the number right there, so just ignore that little thing right there. Okay, we're going to complete the square. I'll do the first one. Whatever number is there in front of x, you divide it in 2. 10 divided by 2 is 5. Then what do you do to 5 to figure out the number that goes in the blank? Square it. 5 squared is 25. So we're going to put 25 here. To maintain the equality, we have to add 25 on the right-hand side as well. Okay, you go through the 2 steps to figure out what goes into the red blank. You take 4 and you do what? Divide it by 2. That gives us 2, and then what do you do to 2? You square it. 2 squared is 4. So you put the 4 there and the 4 there. We can now factor the trinomials. Remember I said there was a pattern. Variable. What am I going to start with here? We're factoring x squared minus 10x plus 25. X, okay. Sine. Okay. And then half of 10 is, it factors variable, sine, half of that number, quantity squared. Now follow that same pattern with the y's. Look at that. We're getting it in the form we needed. I can already tell what the x-coordinate of the center is going to be. What's the x-coordinate of the center? Look in there. I can tell the x-coordinate of the center. Okay, so change sign, so it's going to be a 5. What about here in these parentheses? Variable, y, sine, okay, number, okay, variable, sine, half of that number was 2. What have we got on the right hand side? 35 plus 25, is that a 60 plus 4, is that a 64? Oh, this is working out nicely. What's the center of the circle? We got it in the form we needed. Parentheses squared plus parentheses squared equals a number. What's the center? Once it's in center, oh, I forgot to tell me to put my square there. That's why y'all are so quiet. You didn't want to tell me I'd accidentally dropped a square. Center, here. Okay, change sign, here. Change sign. Radius, we take the square root of 64, which gives me an 8. Change sign, take the square root. This process is called completing the square. We completed the square for the x's. We turned this stuff into a perfect square trinomial that'll factor as a binomial square. We did the same thing for the y's. And remember, if we're drawing a graph, we need the center and the radius. That's what we have. 5, negative 2, and a radius of 8. So, click the circle. 5, oh, hey, wait a minute. Look at that. Each one of these tick marks is 2. They're going 2, 4, so be careful. So I wanted what, a 5, negative 2? No, that's 6. There's 5. There's 5 negative. Oh, I did it. Clear. Let me start it all over. Circle 5 negative. I guess I should get a mouse pad up here, but then I wouldn't have anything to complain about. I wouldn't be able to complain about the touchy mouse when I mess up. So. No, it's counting by 2. Each one of those tick marks is 2. So there's 5, negative 2. And the radius was what? 8. So we're going to count. What do y'all want to do? Y'all want to count up 8? So we're at negative 2 plus 8. Is that going to put us at 6? Let's see. Negative 2 plus 8. I think that's it. I think that's it. We went from negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Be careful, especially for these where they're incrementing by units of 2. Be careful they're counting. Any questions there? If your equation is in expanded form, you have to reverse the process by completing the square for the x's and the y's. Your goal is to take an expanded equation and make it look like center radius form. Number 9. Let me write the problem down. X squared plus y squared minus 4x, is that a plus 6y minus 12 is equal to 0. Okay, well, first of all, collect the x terms together. X squared plus, x squared minus 4x plus, skip some space. And now the y terms, y squared plus 6y plus, skip some space. What are we going to have to do with this constant term here? Where do we want the numbers, this constant term? Up here it already started where we wanted it. On the right side. So what do we have to do with that minus 12? Add 12, I agree. And we still have a plus red blank and a plus green blank. What's going to go in the red blank? I'll get us started. We take that number in front of x and we divide it by 2 to give us 2, and then square it to give us 4. Pretty much the same way we did like this. Half of 4 was 2. 2 squared was 4. So we add 4 to the red blank on the left, and we add 4 to the red blank on the right. Okay. Now we're going to take this number here, 6. What do we do first? Divide it by 2. That gives us 3. And then 3 squared is equal to 9. So we put the 9 here and there. X squared minus 4x plus 4 is a perfect square trinomial. It's going to factor as a quantity squared. What's going to go in the parentheses? I'm waiting. X. It's either a plus or minus. Number. Not 4. Because if we put a 4 there, 4 times 4 would have a 16. Okay. Variable. Sign. Half of that number was 2. Notice it factors very nicely. Variable, sign, half of that number. Following that same pattern here, plus, let me move this up. What are we going to have inside those parentheses? Variable, sign, number, I agree. Variable, sign, half of that number. Oh, this is working out nicely. What have we got on the right? 25. 12 plus 13. I agree with 25. What's the center of the circle? 2. Negative 3. I agree. Change signs. Change signs. What's the radius? You take the square root of 25, which is 5. So we go over to draw the graph. Click, circle. Oh, this is good. It's incrementing back in terms of ones. So the center is at 2, negative 3. And then the radius was 5. Well, let's count up to the right 5. 1, 2, 3, 4, 5. We were at 2. We moved over 5, so now we're at 7. Any questions there? Number 10. Oh, look at this one. Find the center, but not enough to draw the graph at least. That's like all they want is just to find the center and radius of the circle. But and they're giving it to us as multiple choice. I'm going to cover those options up so y'all can't jump ahead before I'm ready for you to tell me the answer. And this is number 10. 3x squared plus 3y squared minus 30x minus 24y plus 120 is equal to 0. Let me make sure I don't miscopy this before I switch to my paper. Okay. Down and down. There, okay. I think we have a major problem here. Before we even start regrouping the terms, before grouping the x terms together and the y terms together, I think we have a problem that needs to be corrected. What's the problem that I'm looking at? Okay, that's right. If an equation is going to be in center radius form, in the parentheses, those coefficients on the variables can only be a 1, which means you can only have an x squared and a y squared. You can't have a 3x squared and a 3y squared. So whatever that number is, divide through by that number. It's the same thing as multiplying, distributing a 1/3 all the way across. You do it on both sides, dividing through by 3. And I think that's going to give us a much better equation. We'll have x squared plus here y squared minus 30x divided by 3 is, okay, minus 24y divided by 3 is 8y plus 120 divided by 3 is 40 equals 0 divided by 3 is 0. So we're going back to that concept of the most basic type of problem solving. If you know how to do one type of problem and you're faced with a different type, try to make this new problem look like the old problem. That's what we just did. By dividing 3 by the 3, our equation now looks like number 9. Just different numbers. So let's group the x terms together. We have an x squared minus 10x plus blank. We have a y squared, a minus 8y plus blank equals, what are we going to do to that 40? I move it to the right, it becomes a negative 40, and we still have a plus red blank and a plus green blank. Because remember, whatever we add on the left side, to maintain the equality, we've got to add it to the right side. So we take the 10, what do we do first? Divide by 2, 10 divided by 2 is 5, 5 squared is, so what do we put in the red blank? Here and here. Okay, what's going to go in the green blank? Okay, you took half of 8. Half of 8 was 4, and 4 squared was 16. You're right. I agree. You were right about the 16. And now we can factor. Okay, y'all answered. Impressed my brother here. Impressed him that I can do this job by myself.
Oh, Tim, you've done the job by yourself for 30-something years.
Yeah, that's true, but still. Here, x, variable, sign, minus, number, 5, I agree. Remember, it's variable, sign, half of that number, plus. Now let's factor those 3 green terms. Y, sign, number, I agree, variable, sign, half of that number. Oh, a negative 40 plus, is that a negative 40 plus 41? That's working out very nicely too.
1.
Okay.
I heard you say.
Okay, so you haven't forgotten your algebra time?
I haven't yet.
Okay. I think we can look at this now and tell us the center. What's the center? I heard 5 and 4. Remember, change sign. Radius, you take the square root off, which is, okay.
Change the sign, square root. Hopefully he said that.
I did.
I know.
Change sign, take the square root. So.
Oh, I was going to punch it in. Oh, wow.
It's multiple choice.
Yeah, which one is it?
Center of 5, 4 and a radius of 1.
Oh, it's X-ray?
Yep.
Huh?
Uh-oh. Her knee popped.
Oh, your knee popped. Oh, I'm deaf up here. Okay. Hopefully it doesn't hurt.
The stage.
Oh,
tell me about it.
Oh, gosh.
Tomorrow is mine.
Oh, wow. Oh, congratulations.
Oh, congratulations.
Birthday. Oh, to be that age again.
Oh, goodness.
Okay.
Time to this is all being recorded. Do number 12? Oh. Okay, number 12.
Oh, look at all of this. You know what, Tim?
Let me write it down.
But there's all these words here and all these things, you know.
Oh, wow. Let's look at that. Let me write down the problem. Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, describe the graph. Realize you can't decide if it's a circle without writing it in center radius form. They ask that as if you can just look and tell by looking at the equation. No, we're still going to have to go through and get it in center radius form. But looking at these,
there's one thing you can decide right off.
Of the A, B, C, D, look at that option C. The graph of the equation is a line. Look at the equation. Point the first two terms. X squared and Y squared. Do lines have X squares and Y squares in their equation? So it can't possibly be a line. A line can only have X and Y. So of the 3 possibilities, we know it's not going to be option C. But let's write it down. X squared plus Y squared plus 4X minus 10Y plus 33 is equal to 0. To decide if this is a circle, you've got to write it in center radius form. Let me make sure I didn't miscopy it. Okay, switch over to my paper. Oh yeah, I know. I've gotten good at adjusting all of that on my own. So hey, are we going to have to divide 3 by anything like we did on number 10? No, because on number 10 we had a leading coefficient of 3. We needed a 1. But here on number 12, it's already a leading coefficient of 1. So at least we're not going to have to divide 3 by anything. We'll group our x terms together. X squared plus 4x plus, skip some space. And then we'll group our y terms, y squared minus 10y plus, skip some space. What's going to happen to that 33? It moves over and becomes a negative 33. And we still have to add in that black blank and the red blank. What's going to go in the black blank? 4. Half of 4 is 2. 2 squared is 4. We can do that in our head at this point. What's going to go into the red blank? Okay, half of 10. Here's your thought process. Half of 10 is 5. 5 squared is 25. So we put the 25 and the 25. So now we can factor the trinomials. Let's factor this. How will the x terms, x squared plus 4x plus 4 factor? Okay, variable, sine, half of 4 is 2, I agree. Y'all see what I'm pointing at? Whatever that letter is there, that's the letter, the first letter in the parentheses. Whatever that first sign there, that's the sign of the parentheses. Half of that number. So I'm looking at the first 3 symbols there to decide what goes in the parentheses. Now the y's. Variable minus 5 variable sine half of that number. Look at the right hand side. What are we about to get there? Negative 33 plus 29 gives us a negative 4. If we're going to find the radius, what do we have to do to this number? Take the square root. So look at what's about to happen. We're taking the square root of negative 4. That's the second lesson in this class. We did it during the first week of the semester. What do we know about the square root of negative 4? What sort of a number is that? An imaginary number. You can't have an imaginary radius. A radius has to be a real number, a distance that you can move left, right, up, or down. This thing is no graph. There's no graph. So this isn't a circle. I guess you could say it's an imaginary circle because you can't draw it. And if you think about it, you don't even have a center point. Because if you plug something in, something squared plus something squared, if it's being squared, it's not going to be negative. So non-negative plus non-negative. Can you add 2 non-negative quantities together and get a negative quantity? If your radius turns out to be imaginary, then you have no graph. Is there a no graph option?
I think it says non-existent. The graph is non-existent instead of no graph.
I think I'd like it better if they said there is no graph.
What would it, in order, like this option here, the graph of the equation is a point. What would the radius have to be for you to have a point, not a circle?
You'd have your center point. What would the radius have to be in order for you not to have a circle? 0, that's right. You don't go up, down, left, or right. Now, Tony, make sure everyone has a copy of this thing here. Let's get there.
One of my leaflets, did everyone get a little leaflet here? Back in the olden days, before the videos and everything, there were a lot of leaflets. I still have these, and I've heard about them every now and then. Sort of summarizing what we're doing over circles. Looking at the very bottom. Oh, you got one.
I've already passed them out. I was just for the people that came in late. Okay. Okay.
I thought it was the one who said you were printing out.
Oh,
No, that's
there's
something
else.
totally
I'll show
different.
it to you in a moment.
Did you finish it?
We did.
You didn't finish
Not
this?
those, I know.
Okay. Okay, well, anyway, let's go back. Looking at this little handout here, writing equations of circle in center radius form by completing the square. That's the step we've been doing the last half hour. So, if the leading coefficient A isn't 1, you have to divide through by that number. That's like number 10. Well, was it 8? Which one was it? No, it was number 10 that we had to, we had to divide through. Okay. Then rewrite the equation by grouping the x terms together, followed by the y terms. Isolate the constant term. That's what we were doing.
I did it right on there. Draw a plus blank after each of them because it just sounded stupid. So, but you always draw plus red blank, plus blue
Can
blank.
you blow that up some?
Oh.
Divide the coefficient of x by 2 and square the number found in step 3. That's what we were doing here. Divide it by 2. Oh.
You let me blow it up.
Divide it by 2 and then square it. That's how I got that number 4.
Right up here.
Repeat it for the y's. Divide it by 2 and square it. So this little recipe is just going through what we've been doing. And then step number 7, we factor it. And then step number 8, to find the center. To find the center, you change sign. And to find the radius, you take the square root. Step number 9, to find the radius, take the square root of the number on the right-hand side. So that's that handout there tries to have, it's a little recipe that hopefully will help you go through this, completing the square process.
But all of that was before the videos. Okay, the videos now you can watch and go through a step.
Blow it up. We have a note down here. If r is equal to 0, then the graph isn't a circle, it's just the center point. If r is imaginary, then no graph, not even a center point, exists. So we go through those special cases there. Let's do another one.
Oh wait, did I don't even remember. Okay, yeah, let's do number 13 to end it up.
Tony, since you're so eager to talk, I think I'll let you.
You have the microphone. You do.
Oh, okay. I'm going to do number 13.
Same instructions. Which answer, if you were just going to guess, which one would you not guess?
When I see the x squares and y squares, I know the graph is not going to be a...
Can't be a line if there's exponents.
They were much more talkative before you
quiet.
showed up, Tony.
Yeah, right.
Okay, let's switch over. Okay, I got to impress Tony with your abilities to complete the square. Do I need to divide 3 by anything here? No, because the leading coefficient's already 1. And then I'll group the terms together. I have an x squared minus 4x. It sure does seem like they like the number 4. They being Pearson, plus, what have I got here? Okay. So I'm grouping the y terms together now, plus skip some space, equals, what do I do with the 29? Move it over, it becomes negative, and I still have that plus green blank plus red blank. So, what's going to go in the green blank? 4, I agree. Half of 4 is 2, 2 squared is 4. Look right up there. It seems like they really like to have those 4s. You keep getting a 4.
Well, you wouldn't want a huge
number,
messy
right?
number.
Yeah.
So.
What's going to go? Well, this is very similar, isn't it? What's going to go in the red blank? 25, just like right here.
Oh,
half
wow.
of 10 is 5. 5 squared is 25. That probably won't happen to y'all. I think my math lab knows that this is a teacher up here, and so they're just trying to make it,
really
easier for us. There. Remember, you have to add the green 4 and the red 25 to both. Oh, this is good. What have we got on the right-hand side? 0. Negative 29 plus 29 is just 0. So is this thing going to be a circle? No, it'll just be the center point. But let's go ahead, and I just have an aversion to stopping there. Let's go ahead and factor the things. Here inside the green parentheses, what do I have? X, I agree. Sign. Number. Variable, sign half of that number. Here in the red parentheses. Y minus 5. But because of that 0, you take the square root of 0, it's 0. So you have a center point, but you're not going up, down, left, or right. The graph is just a point. If the radius is 0, graph is just a point. It's not a circle.
In fact, you can tell me what that point is, Tim.
It's the center point, which would be, what would that center point be? 2, 5. Change sign to get the center. But they don't ask what point it is. They just want you to select.
But I've seen some of the new additions, and it does on this type of problem where it says the graph is a point, it then says the point is, and you have to type it in. But we haven't gone to that yet. So that addition. Let me see. Does it tell you which one it's? I don't know. Anyway.
Check answer.
And I think number 14 is a good old cut point. Yeah. Okay, just review from there. Now, what I've been doing.
Okay, are we ready to start recording before? Any questions?
Oh, I'm going to go ahead and record this just so y'all see.
Okay.
I'm not. Where's the other? Oh, okay, there. Okay. If you're logged into Pearson under document sharing, I am very proud of myself. I found all the notes that aren't in this book, and I separated them out based on which class it was, Monday, Wednesday, or Tuesday, Thursday, and I have PDFs here. Under document sharing, there's a lot of stuff here that y'all don't see. All y'all will see are these 3 things. Cut points, circles, I just handed out, and this thing that says Class Lecture Notes Fall 22, Monday, Wednesday, Part 1, lecture notes to go along with the videos. If you click on it, it will automatically start downloading on your device.
You got to move that up.
Yeah. See, so it's right here. Oh yeah, right there. I'm going to click it. A student asked if he could, he couldn't read some of his notes, and so I said, okay.
Well, I said he could just use our notebook, but there's stuff in this notebook like test questions and stuff like that.
No, you can't just give a random student that notebook. But here it is.
You didn't Xerox any of the stuff that was.
This is just what we've done in y'all's class up to, and before too long we'll have the rest of it. It ends at lines, before lines get started. Okay? So these are all, and if you want to see these problems worked out, that's what the lecture video. Like on the assignment 6, rational and radical equations, it was on September 14th that we made the video and discussed them in class. Here it is, the stuff that he wrote up.
I'm going to take that file that Tony put on document sharing on my math lab, and I'm just going to store it under files on Canvas, because I think that's quicker, right? Y'all see the stuff files on Canvas quicker than going to document sharing, right, or not? But I'll put it up there.
This document sharing is where I store. This is my cloud if I need to store stuff. Okay. But anyway. So any questions? What that is? If you want to look back at the notes,
what we were writing during y'all's class,
up to but not including lines. I'm going to start a new one that says Part 2, and it'll begin with lines. Okay. Any questions on that? Because now I'm going to stop the recording, or have I already stopped the recording? Oh, no, I haven't. Okay. Oh, good, Tim. Only an hour and 28 minutes. You really stood.